What might be a typical Formula E lap time? I'm trying to gauge how long the engineers have to update their calculations.
A little bit over a minute.
Oh, jeez.
Yes, comes up pretty fast.
From TECHEETAH Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. We're kicking off our second season with a pioneer of Formula E motorsports, five-time Drivers and Teams champion, Mark Preston. Mark Preston has described motorsports as a prototyping competition. It is an apt description, especially for the all-electric Formula E series, of which Preston was a founding team principal in 2014. Since then, he and his teammates at DS TECHEETAH have become five-time winners of the Formula E Drivers and Teams Championship, earning back-to-back wins the past two seasons. In his spare time, Mark is founder and chief strategy officer at StreetDrone, an autonomous-ready development platform designed to democratize world-class research and development. He's founder and director of the Oxford-based Mobox Foundation, an organization dedicated to solving complex problems in future transportation and mobility. And he's the founder of Preston Racing, providing technical and strategic consulting for motorsports companies and other enterprises. Oh, and he accomplished all of this after a successful career in Formula One racing with teams like McLaren and Arrows Grand Prix. Mark operates on a whole other level, so I thought it would be fun to chat with him about the engineering significance of Formula E, as well as the big problems he's yet to solve for humanity. Really, very much a pleasure to have you here in Moore's Lobby. Let's start with the obvious thing. Your team is now, five-time champion?
That's right. Yep, 3 drivers and 2 teams championships.
That's incredible. Tell me about, Mark, the success. What does it take to create a team, to create a culture, to create the technology to enjoy this much success in something so new?
Yeah, I mean, people ask us, quite often, what's the silver bullet? What's the magic? But when you really look back at kind of how we got to where we are, many of us, I was one of the founding team principals of Formula E, so I've been in it since the beginning. A number of the key engineers as well joined. I met them in season 2, Pascal, Leo, Clement, the guys that do all of the software side of things. And then, of course, our driver, John-Eric Verne, we joined him in season 3, so he's been, with the team for 3 years. And just recently we had Antonio joined us in season 6, and well, he actually worked with us in season 1 actually, and 2. Yeah. So for me, it's kind of, when you look at many companies, sometimes you sort of think it's something like Google. Oh, they're pretty new. Actually, they've been around 30 years, and it's a similar kind of thing with us. I think we've kind of all been together for quite a long part of this journey in Formula E, and so that's a big factor. And then, of course, everybody's important. So I think we've got some of the fastest drivers. The series is very biased towards drivers because they've got to do a lot of work in the car, managing energy. The cars are quite difficult to drive. We're in cities. It all happens over one day, which means that you've got to arrive and get it right and not make any mistakes during the day. So it's a lot of marginal gains, I think. There's a lot of the discussion about that. I know the guys in Mercedes talk about that, and certainly Sky Tour de France team also talked a lot about marginal gains, and I think that's correct with us. So the sort of long sort of story about this and coming around to it is we've all been together for quite a while, and we've built up to this point. So nothing happened overnight, and there's just lots and lots and lots of things in the background, everything from the best powertrain from DS automobiles to the best drivers to the great engineers to everybody else that's helping behind the scenes. So it's very much a team effort. Absolutely, and that's part of the appeal, certainly of any motorsports. Is the driver gets the glory, right? But it's the performance of the team, I think, that really impresses true fans of the sport.
And in the case of Formula E, can you describe for me why driving the electric vehicles, as you said, is difficult? Is it more difficult, say, than Formula One? Is the dynamics of the vehicle? What are the challenges there?
Yeah, I mean, a number of the differences between F1 and Formula E. F1, you arrive on a Friday and you've got an hour and a half in the morning, hour and a half in the afternoon. You got the Friday to think about it. Again, next day you got practice session, qualifying, and the next day race. So you can sort of build up to a typical, what's typical in petrol motorsports, internal combustion engine. Whereas in Formula E, it's arrive, you start at sort of 7 or 8 in the morning on a Saturday, usually. Small, short sessions in tracks where there's walls everywhere, which makes it quite exciting. And then you go straight into qualifying it, and we have a different type of qualifying than many other motorsports, which also throws another big parameter into it, where if you're leading the championship, like our guys have been quite a lot, you start in the first group, and it's very hard to explain, but the first group is usually a lot worse than the second group that goes out because they're cleaning the track, basically. Oh. And in order to get out of that group, you've really got to perform on in your one lap. And then if you can get out of that group and effectively be on provisional pole, then you've got a very good position to be in super pole, it's called. And if you can get super pole, and that's the last 6 people that got into that super pole, go again, and you might get pole. And if you can do that, then you will be starting the race from pole, and then you've got to win from that position. So, and that's all in one day. And that's one of the biggest differences, is it's all together. If you make one mistake in where John Eric made a mistake in one of the free practices in Saudi last year, and that meant his whole day was really put out of joint,
Mm-hmm.
So it's a lot about that. The F1 cars are faster and have more G-forces, etc. But we sort of race on Monaco every weekend in a way. So yes, an F1 driver that's good at Monaco would probably be good in Formula E. And many of the drivers in Formula E have done Formula One, or at least testing. John Eric was in Formula One with Toro Rosso, and Antonio certainly tested a lot of the cars for Red Bull. So yeah, it's different. There's different challenges, and they really test the drivers, I believe.
Well, it sounds like it, and like you said, energy management. It's not just monitoring any more fuel. Are your tires too worn? Now it becomes, all right, how's my battery, and do I have enough energy in my vehicle for that crucial final couple laps, or to overtake this person but then still maintain a lead? And is that a combination of vehicle smarts communicating back to the driver, or is it driver intuition? Is it a combination of both?
Well, basically, if you think about it kind of simplistically, the total race, there's not enough energy to do the total race flat out. In fact, you have to regenerate something like 30% of the energy in order to finish the race in the fastest way. So the driver has to be doing, we can't have electronics that do all that automatically. So they've got to pull these paddles on the steering wheel in combination with brakes to regenerate the energy in the right places. But when you're regenerating energy, sometimes you're going a little bit slower. So you can't get overtaken by the guy behind while you're trying to save energy, protecting from him, maybe try to overtake someone in front of you. Mm-hmm. There's quite a lot going on. And then we can't see the energy on the car. They have to tell us that every lap. And if they miss a lap and don't tell us what the energy is, our engineers can't do the calculations and predictions to give them the concepts to do on strategy. And then not only that, we have an interesting thing called attack mode, where you go offline into you go through these two sort of segments, and you get given more power for about 4 minutes on average. But when you do that, you lose time as well. So there's a lot of little things in Formula E that make it quite difficult, that the drivers have to understand, have to be able to manage, and do better than the others, of course.
Absolutely. All the basics. What are the, obviously lap times are going to be all over the place, but what might be a typical Formula E lap time? And I'm trying to gauge how long the engineers have to, update their calculations and provide feedback?
A little bit over a minute. Over a minute.
Oh, jeez. Oh,
So,
man.
Yeah, so it comes up pretty fast. Yeah, you're right, because that's why now we have a lot of software. In the beginnings of Formula E, we had some sort of pretty sketchy spreadsheets, which you were trying to check, in that minute. But now our software's got a lot better. So at least once the driver gives us the energy level, then the software recalculates. The engineer might make a decision and then tell the driver to change something, in that lap or halfway through that lap. So it's pretty fast paced and lots of pressure on the drivers and the engineers.
Yeah, it sounds like it. I mean, sometimes it takes me longer than a minute to successfully enter my passcode into my iPhone to unlock the screen. Can't imagine. And then when you're the driver and you're waiting on those numbers, it's like, come on, guys. But that's intense. Hey, everybody, it's Dave. This episode is sponsored by AVX, a leading provider of advanced electronic components, interconnect, sensing, control, and antenna solutions. AVX is a proud partner with the Dragon Penske Autosport Racing Team in the Formula E All-Electric Racing Series. AVX offers automotive EV and HEV component solutions for powertrain, active body control, ADAS, lighting, power conversion, drive control, and more, all manufactured to the highest quality and reliability standards. Their long track record and more than 30 years of expertise in automotive products enable customers to rely on AVX as the one-stop source for passive components needs. For more information, visit avx.com/formula-E. Can you tell me a little bit about electric vehicle drivetrain specifically for motorsports? Because I see this being, innovations there that can be done at scale, trickling down and benefiting many of us. What were the challenges, the big things that you were solving for when you were advising these teams on drivetrain development, that sort of thing?
Yeah, I mean, probably the best way of describing that is in season one, we all had the same powertrain, but it was supplied by an external supplier, and you couldn't do a full qualifying lap without the part of the motor overheating. So you had to manage the temperature of the electric motor. You had to be careful of the battery. You couldn't regenerate too much into the battery.
Mm-hmm.
We had 5-speed gearboxes at the beginning because at the time that seemed like potentially the best trade-off. But then if you move forward to today, they're basically direct drive motors. They don't overheat. They don't have really any thermal effects from qualifying lap. They don't have any problem with the battery. The battery doesn't have any issue with any of the, they call them drive cycles that it has to achieve. And so, I mean, not only have we moved towards a solution that is obviously fast and efficient, we've gone from 2 batteries to 1 battery. There's a lot more software associated with driving the car. You can see that that's come through into road cars, for example. So I've got a DS3, which is one of the DS electric vehicles. Mm-hmm. And I was actually driving it today and, playing around with some of the parameters, which I know are similar to the race car. So as you come up to a corner, for example, when you lift off the throttle, you'll see it recharging. And then as you touch the brake, it actually does more recharging until a point that it actually applies, let's call them the real disc brakes. And so as you watch that speed come down to the corner, that's exactly what happens in the race car. And so the more that the car companies learn about what's best on the racetrack, the more you can see that, when you're driving your actual EV around town.
That's, to me, seems like the real advantage for humanity. Obviously, everybody benefits from, I guess, what could be described as almost like a extremely high performance prototyping lab or research and development lab, which is the spirit of Formula E, is it not? Yeah,
I mean, in some ways you could call them, if you've ever had a look at something to do with NASA, they call it technology readiness levels, the thing that sort of says, when you go from blue sky research all the way to something that's fully commercialized. We're probably at the technology demonstrator phase where we are trying ideas, quickly iterating. If they don't work, of course, we won't run them anymore. So you can see that the other benefit of motorsports is that you try things, you compete against your peers, like all the other car companies, Porsche, Mercedes, etc. And the best ideas win. And then the sport does start to iterate towards solutions that are similar in a lot of areas. And then once those iterations start to be validated, then it's obvious that there's no point in developing a road car with some technology that didn't work in a race car, because you've run it at the very, very top and competed against everybody else. So you'll find that in the first year, I think this is the best example I can think of at the moment, because they were 5-speed at the beginning. You don't see don't see many electric vehicles with gears on the road, and that's probably borne out by the fact that in Formula E, quickly people iterated away from that to a better optimal solution.
See, this is I didn't know that. I'm if it's not already abundantly clear 17 minutes into the conversation, I'm very not knowledgeable about cars.
Okay, no worries.
So when you refer to the electric motors, obviously, maybe I should back up one step. So a motor essentially on each wheel, yeah.
Mm-hmm. Oh, okay. No, sorry. One at the rear. We've only got one at the rear at the moment, which goes through a differential and is split mechanically to the rear wheels, and that's just to stop people doing torque vectoring. Really, that was the original idea.
Okay. So now I'm starting to piece this together. So yes. Mechanically, still one motor driving multiple, and so that's
the rear wheels.
Yep. That's really a lot of pressure to put on that motor.
Yeah, I mean, you can see some of the pictures of the motors online, and they're pretty small, actually. That's quite amazing how much power comes out of these little motors. They're quite incredible.
Now, how are the sort of the innovations that you are continually making, how are these then disseminated into the world? Are they available through, is it intellectual property that companies can purchase? How does that work?
Yeah, I mean, because we're partnered with DS Automobiles, the technology really goes straight back into their road cars. So they take all the ideas and look at the winning concepts, let's say, and then work with their colleagues in the road car section. They also find that many of the tools that they use in the race car development can then be used to speed up processes in the development of a road car as well. So validating not only concepts, but also processes, procedures, and other things that might be quite mundane to some people actually help to speed up things, because in the heat of battle, let's say in motorsport, you're often pushing things further than you are in road cars, and therefore it's easier to kind of break something in a race car. So you kind of always operating up in the 98, 99, 100% range, whereas a road car probably doesn't always run in those ranges. So that's always a good test of technology, because if it works and you can validate things and quickly develop technology in racing, that will work in road cars.
Yes, and this appears to be one of your superpowers. It appears that the theme of your career has been how to make stuff, and then how to make stuff viable, and then how to make stuff viable and do it very rapidly. So if we look at sort of the timeline of your career, you were designing hazardous material tankers.
Yes.
Can't really make any mistakes there. So,
no.
So then with all the success there, what came after your sort of initial work as an engineer? Can you sort of describe the timeline of your career?
Yeah. I mean, I started in doing dangerous good tankers in Australia, and then I moved into automotive. So I went to GM, where I started working on crash testing, the very, very beginning of using computers to simulate crash testing. So I did it quite a few years there. And then I had the opportunity to come over to the UK and work in Formula One when I continued to do simulation. So I've always done mathematical modeling of mechanical systems. So I did what they call stress analysis, which is working out how strong things are and how light you can make them. So I did that for a lot of time over my career in F1, doing things like composites, carbon fiber, design and manufacturing, crash testing in race cars. I also did a lot of things to do with vehicle dynamics, software and simulation. And then I moved on to sort of moving a bit more back to the business side of things, which is when I started a Formula One team with Honda called Super Aguri in F1, where I was the technical director. And I sort of started to become more generalist as I, became into more senior management. I then actually started a composites company for a few years, again, doing carbon fiber manufacturing. But when Formula E popped up, I had been looking at electric motors. I'd started to help a spin out from Oxford University called Oxford Yassa Motors and got interested in all of the business modeling and understanding that things were happening and changing. And this was back in 2008 and 9. And then the FIA announced this new racing series in electric, and I got myself involved in that and really kept going in that side of things to do with electric cars. But in parallel with one of my old friends who just sold his business in the digital analytics business, we started an autonomous car company. And that also starts to look at its simulation software. And we've taken a lot of the concepts and ideas from race cars, actually, across to build these autonomous cars more quickly. So we use a lot of ECUs, so engine control units in autonomous cars, wiring systems, electronics, and a lot of other concepts from motorsports, because it is a prototyping business as well. So I suppose all my career has always been trying to be at the cutting edge where there's not that many people playing yet, where nobody can tell you the answers, and figuring it out first gives you an advantage. So I think that's why I like motor racing, and that's why I've liked getting involved in things like electric vehicles and autonomous vehicles, because we're still, in the early stages of those parts of the industry.
Well, it's so cool because you don't seem like somebody who gets complacent and waits around. And I think a lot of people in their career, maybe if they have an opportunity to work on something new, bleeding edge, and very cool, sometimes it's easy to get complacent and say, yeah, this is nice. I've carved a little niche for myself, and now I'm going to play it safe for the next, say, 30 years while my 401k, adds value. But in your case, at every stage, you've said, all right, cool, problem solved this far, and now I'm going to hand it off, and you guys run with it. I'm going to go start this other thing. I was reading you were able to stand up that racing team in 90 days. Is that right?
Yeah, that was 100 days, so 10 more days than you're saying. But, that was...
oh, come on, man.
And I think that might have counted Christmas as well, I think. I can't remember if it was Christmas as counted or not. But basically, it was pretty close to not going home for Christmas. My wife, I think, remembers that. Yeah, I always through my career, as soon as I realized that, I'm not going to say everyone can do it, but when it becomes well known and understood, I've usually moved on to the next thing. I certainly did that quite a lot of times over the period, and maybe that's a dumb idea. Maybe I should have just stopped at one point and said, okay, I'm the expert in this field. Let's stay stationary. But that's, for me, it just gets too boring if you do that. So always trying to move forward and work on the unknown, I suppose. Pioneering work is always the best fun.
So I ride a mountain bike, and one of the keys in mountain biking at very high speeds is to be looking way ahead on the path, and really to only keep your eyes on where you want the bike to be. And I think the people who get distracted by what's happening right in front of their tire, or is that tree over there something I'm going to smash into? Well, that's when you smash into the tree, or you drive your bike into a rock and go flying. And it sounds like throughout your career, just the way your mind naturally works is you're looking so far down the path that by the time you are immersed in something, your subconscious is already evaluating, where can I apply this next? Do you? And I think that that's something that I admire, because there are so many problems to address and to solve in the world. I mean, vehicle electrification is one of, 10 billion things that we need to figure out to improve quality of life all over the world. And so you've also been able to apply sort of your race car of a brain to philanthropic initiatives as well.
Yeah, it's always trying to think forward, and one of the things that we enjoy about this world of EV is, we've got a partnership with Big Cat Sanctuary, and so we're looking to the future. We're trying to understand. I'm certainly always trying to understand more elements of sustainability and what and how what we're doing can impact the future. I mean, obviously, electric vehicles are zero emissions at point of use, but we still have to solve the renewable element. My electric car's okay as long as I can put green energy into it. That's when it really starts to pay dividends. And also, when you manufacture the vehicle, the more green energy you can use in the vehicle manufacturing and its total supply chain means that the total vehicle's life becomes carbon neutral. So you can also see in Formula E, we're the first sport to become to be certified as zero emission since point of use. Since the beginning. The wrong word. And so everything around us is trying to focus on that, because without EVs are great, but unless you get also renewable grids and renewable energy, they don't really fulfill their full benefit. And that's why we're working with the Big Cat Sanctuary. Our name's obviously TECHEETAH, so kind of tech and cheetah.
I love
that.
So
we work working with them. So each car's got a name. Keen and Bajrami. I can't say it very well. I've got some photos of them in my office here. Actually, they're pretty amazing animals.
Yes.
So yeah, it's what's really nice about being in Formula E is that you start to join up some of these elements of the total ecosystem in our discussions, and that's quite exciting as well.
Yes, benefiting many from what we learn, in these sort of micro slivers of things that we're developing, and like you said, the initiatives around zero emissions and sustainability, renewability. A lot of these technologies are so complementary. Everything from sustainable energy to power a factory, relying on things like inverters, energy management, energy distribution, and that's exactly what's happening on a much smaller scale inside of a vehicle. So, and what about, can you tell me anything about end of life for electric vehicles? Because at the end of the day, again, let me preface this by saying, if it's not clear, I'm not the smart one in this conversation, but I do know that I've got a big cardboard box filled with batteries just from my kids' toys that I don't know what to do with to recycle them properly. I can't imagine what you're looking at to solve that problem for end of life on a lot of electric vehicles.
I mean, one element of this is it is quite difficult to recycle the batteries themselves, but in our race cars, we need the batteries to be operating in the top, above 90% range. However, if you were to use that same battery once it's finished being used in racing for, let's say, a backup system for a hospital or some sort of, a house battery to take the solar and store overnight, the second use or second life concept is quite useful in our batteries, because I suppose different to the batteries in your, the ones you buy for your toys, etc. If you've got rechargeable ones, then I'm sure some people can use those for a lot longer, because maybe they only need to be able to have the capacity of 40 or 50%, as long as the battery management system can understand what's happening with the battery. The same for our batteries that we're using, because they are charged and discharged quite a lot. So they lose their peak performance. But if you're just looking at a backup system, that only discharges every couple of days when they test it. Otherwise, it's the power's being, kept in a, like a UPS type thing. Then there's lots of second life uses, as say, especially helping in storage for, renewable energy. So that's one of the biggest areas. But there is a lot of work going on still with full recyclability of everything, including, most road cars have to have a very high level of recyclability nowadays. I think it's above 90%. So, yeah, it's coming, and everybody's very aware that that's the area for work. But some of the good things is you can leave behind kind of a legacy system. Let's say, when you put emergency power, or there's concepts about having a containerized battery that could be taken to a war zone, or somewhere where there's been a problem, a big health scare, or a cyclone, or a hurricane, etc. And you could land one of those batteries that can store in a mobile sense.
I hadn't even thought of Second Life, which is why I designed stand mixers. But anyway, that is absolutely brilliant, because I think of developing nations where we know that infant mortality rates are so high because they don't have power. If the village is relying on solar power throughout the day, but the baby's going to be born at 1 a.m, they don't have light, and they don't have equipment being powered, and these applications. I just think it would be cool to know that I might have had Antonio Felix da Costa's old battery backing up my stuff. That would be cool.
Yeah, I mean, I've actually been to Zambia a bit, because my family helps with vulnerable children in Zambia, and when the power goes off, they just turn it off, and they say, no, we're load shedding all of these towns, as you say, and if you don't have backup generator, then everything just goes dark for a few hours, and then it might come on later on, or maybe you have to wait till the next morning. So there's so many places and examples, and the more that you look at things like it's like decentralized. So, if you're in the north of the UK, or in America, out in the middle of nowhere, Australia, where I'm from, then you can have a solar array with a battery pack, and you don't need to be connected to the big cities, maybe on the coasts and stuff. So there's a lot of development going on with that element. And then there's a lot of discussions at the moment about, the hydrogen economy, and how else we can move energy around. And one of the things that I like that VW says is that, the battery is just one type of energy carrier. You carry the energy in a battery, but you could also carry energy in other ways. And that's what's so exciting about what's happening next in this whole renewable economy that's kicking off.
Absolutely. And so right there, all the sort of bells and lights and indicators are going off in my mind. New problems to solve, and that's got your name written all over it. What are you looking forward to at this point in your career? What problems are you just really eager to tackle right now?
I think the next one is really this whole renewable element and angle to it, because we've got the EVs now off and running, and they're seen as something you can buy for an everyday car. I think the next step is now pushing to have more and more renewable energy on our grids, and the hydrogen element could be one of the solutions, or at least part of the solution. I know they're not the most efficient. It's better to have a solar array next to your car and charge your battery car. But if you've got a lot of energy in places like Australia or the middle of the US, then it's no point in wasting that energy either. You can use that for other things. So I'm quite interested in this whole renewable economy, and of course, getting everything down to basically to zero net carbon. That's got to be the next target.
A million questions about this. So what what are the largest barriers that you're perceiving right now to getting us where we need to be 5 years, 10 years, 15 years? And I ask that, by the way, as somebody who is apologetically an American citizen, and it seems the last 4 years America has decided that, screw the future. How does my stock portfolio look today? So the culture here in America, certainly at the political level, at the highest political level, has been, defeat renewable energy. Let's reinvest in oil and coal. Other than boneheaded politics interfering with things, what are some of the largest obstacles that you perceive?
I think it's just, charging infrastructure, the infrastructure to go behind the vehicles.
Hmm.
I think just market acceptance. The early adopters like myself were already starting to play with electric vehicles. The more that in Formula E we can educate, the world that these cars are actually fun and exciting to drive, and you'll be able to use them, every day. I think that's a big step. And
Hmm.
then the prices of solar and other things are dropping dramatically. And because they have dropped below some of the numbers, like for coal-fired power plants and things like that, in certain places, it is just the right thing. I know that the big Tesla battery they put into Australia, initially people were skeptical, but now there's other states in Australia putting in the batteries because there's plenty of renewable energy going onto the grid all the time, but now they need to load balance it. But that's okay because then secondary things come out of it. I've noticed also when we travel to South America and other countries where they were always based too much on oil, but as they've been able to decouple themselves from the oil price, then they're more resilient. So it does feel like there's lots and lots of things happening in the background as the prices drop of all of these elements. It's great seeing Tesla in the FTSE 100 because then it becomes more visible, and obviously it puts more emphasis behind this move to the renewable sort of economy. So I think it's a matter of investment infrastructure.
Hmm.
I think it does feel like it's one way we're all going to get out of this current big Malay problem that we have, obviously with COVID and the effects of not only economically but for people.
Yeah.
I think it will be part of the recovery, I think, and that's what is potentially one of the good things that comes out of this time period.
If we look at this globally, where do you see the most exciting things happening, like geographically in the world?
No, that's a good question. Yeah, that's an interesting question. I mean, I'm fascinated by places like we went and raced in Uruguay, and I think they're now 100% renewable. Now they do have a lot of hydro down there,
Hmm.
so do places like Canada, of course. So it's really interesting when you see big audacious projects happening. I know in Australia they're looking at some big audacious, let's say, solar farms in the north of Australia, which is exciting.
Hmm.
There's more of them happening in the Middle East. We're going to race in Saudi at the next race just after Christmas, and that's going to be a night race, but it's going to be fully renewable. So all the energy will be coming from renewable sources. So
Cool.
those kind of big steps are great. Formula E itself is working more towards having hydrogen charges for everything. So all of the generators at the track are using renewable sources. So we're making nice, big, bold steps, but everything takes time. When I think that I did my first sketches about Formula E back in 2009, it shows you we've come a long way. But like I was giving that a Google example before,
Yeah.
but it's actually been a long time. So I think time does, things do take time, and I suppose we just got to try and help accelerate things, and that's the best we can do. Just keep pushing forward.
Yeah, and this I love Formula E because as an organization, because this that culture just seems to hit every corner of Formula E. Earlier this year I had the privilege of interviewing Lucas di Grassi,
Hmm.
and then one of his partners in Robo Race, for autonomous research,
Yes.
Bryn Balcom, and
Yes.
it was so fun talking to them because everything was about the spirit of innovation. And then if I can demonstrate it in this vehicle, we know that we can apply it over here to solve these other problems.
Yeah, it's trying to pioneer, push things forward, trying to be at the forefront. It's really exciting, and I think we've even put a little bit of pressure on Formula One because they're talking a lot about the future as well.
Hmm.
Now they always did, but they're pushing a lot on the renewable energy or renewable ideas and using synthetic fuels in the future. So it's great when all of motorsport is pushing forward to trying to find new ideas. I mean, there's even the possibility that people that are racing old classic cars, we may be able to come up with, or maybe it won't be me, but there's a possibility that they could be using synthetic fuels which have come from renewable sources in the next 5 to 10 years, which will be exciting as well. So then even some of those gas guzzlers that sound good, etc., can maybe be green as well to a certain extent.
Yeah. And by the way, I love quiet cars. I just when I was younger, I loved loud cars, but now that I have kids that I desperately want to have them sleeping through the night.
Yes.
But the thing is, the most impressive cars aren't the loudest ones. It's usually like a Honda Civic with, these ridiculous, but, the last little bit here, my big takeaways from this conversation are just how excited I am that we have minds like yours who are solving real problems in an appreciable way that we know can be adopted. But I'm left with sort of two questions, and they're more maybe philosophical, floofy type questions.
Yes.
One is, I'm fascinated by the sort of the evolution that it sounds like you're kind of describing in Australia's technology development culture. Is Australia becoming an area that is focusing on rapidly, developing new technologies?
Not having lived there for quite a while now, I can only sort of analyze from the outside, and also what I obviously hear from my friends and family and colleagues, etc., in Australia. There's certainly a lot of discussion at the moment about what is Australia's strengths. Mm-hmm. And one of the areas is obviously a lot of sun, and so maybe it's just me listening to a lot of the discussions about renewables, and that's why I've been starting to read a lot about this hydrogen economy concept, where you've got a lot of space with a lot of sun. That doesn't seem like it's worth wasting that sun. At the beginning, it may not be as efficient as we would like in order to transport that electrical power to other countries. There's been a bit of discussion about Japan being a very large net importer of energy, mm-hmm. and maybe being able to bring energy from Australia. At least at the beginning, Elon Musk is correct when he says the efficiency of taking the sun in Australia and taking it to Japan is not great. Mm-hmm. Down in the sort of 20% range, where it is much more, it's much better just to take energy in a country, let's say, and directly transfer it into a car, for example. The percentage then is way up in the sort of 80% range. So mm-hmm. there's a lot of work there to do there. But, in a country like Australia with so much sun and natural resources, it just seems logical that that's the next place to look. And as you were talking earlier, I like to make sure I'm at the very forefront, and that does feel like it's certainly got some possibilities. There'll be some naysayers, but when you're at the beginning of a technology revolution, at the beginning, it's someone said to me, if 50% of people think you're wrong and 50% of people think you're right, then do it. If 100% of people think you're right, then it's probably not a good idea. So
I love that.
I think at the moment there's enough people saying they're not sure to say, oh, it seems logical. I need to do a bit more reading and a bit more research. And you never know what happens. One of my best experiences in motorsports is, when we were doing that, starting that Formula One team in 100 days, some days you'd go home and think, oh my God, we can't solve that problem. And then you wake up at 5 a.m. the next morning with an idea, driving to work as fast as you could, and everybody else was all there, and you're all throwing your ideas around, and we had it solved by lunchtime. So I'm not saying that anything's possible, but I have experienced in motorsports when things seem impossible, we always seem to have found a way to solve it. Maybe it's not directly through the middle. Maybe we've found a way around it, but that's what makes it really exciting. And I think that's what makes, this technology sort of game, really exciting. And that's why it looks really good for the future.
Well, I'd like to thank Mark Preston for making time to chat with me today. Be sure to subscribe to Moore's Lobby on any of the major podcast platforms, including Apple, Spotify, and Google Podcasts, to enjoy new episodes every 2 weeks with industry experts from world-renowned companies who join us to chat about leading-edge technology and engineering topics. You can also follow us and catch prior episodes on allaboutscircuits.com. Until next time, thanks for listening.